Welcome back to the video series on questions for revision. At this video, we will see questions from continuity and differentiation. Reference material in all chapters of class 12 mathematics is available easily to all the students, but the students are not able to gather necessary help because they need detailed explanation of the solution steps, recollection of the concepts required for the solution, tips to do problems, and tips to reduce errors. The above needs of the students is taken care of at this tutorial series. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. To ensure that 10 questions per selected topics is compiled at this video, the answers to the compiled questions is presented in PDF and video format. Students are hereby requested to start your revision by downloading the questions for revision. This material is only a supplementary to the revision strategies planned and executed by your experienced teacher. We'll move on to question number 1. You have to prove that the function f of x is a greatest integer function is continuous at. But all of you know directly that greatest integer function is not continuous at integers. Directly you can write the answer. But suppose if this problem is asked for 2 marks, you have to do the working. Therefore, I have here shown you the working. For any integer a, f of a is a. For a plus, when you want to find, that is a right hand side limit, will be a. When you find the left hand side limit, it will be a minus 1 because a minus is less than a. Therefore, left limit not equal to the right limit. Therefore, it is not continuous at integers. Out of all the options given over there, 1.5 is a non-integer. Therefore, that is the answer. You can write the answer directly for 1 mark. Suppose if they ask you in 2 marks, show that the function f of x is a greatest integer function not continuous at integers. You have to follow these steps. We'll go to question number 2. You have to check out for what value of lambda this function is continuous. This type of questions are coming in 1 mark also, in 2 mark also. You know that you have to use the condition for continuity to check the value of lambda. F of x is continuous, limit value is equal to functional value. Where I am using for right sided limit, I am taking the function opposite to greater than 0. For left hand side limit, I have to take the function just opposite to less than 0. You remember like that. Then f of 0 is wherever the equality sign is there. I am checking out that 1 is equal to 0 is equal to 0. Is it possible? No. Therefore, the option is C. There is no value of lambda for which it is continuous. Therefore, no possible value exists. Question number 3. For sin x plus y is equal to log x plus y, then we have to find dy by dx. I am using differentiating with respect to x. Cos of x plus y into differentiation of x plus y. 1 by x plus y into differentiation of x plus y using chain rule. Differentiation of x plus y is 1 plus dy by dx. There also 1 plus dy by dx. Therefore, dy by dx has been taken to one side. And I am finding what is dy by dx now. Numerator and denominators are same with a minus sign. Therefore, the answer is minus 1. Question number 4. If y is equal to log of x plus root x square plus 1, then dy by dx at x is equal to 1 is. Therefore, the chain rule will be coming everywhere. Therefore, the students are hereby instructed to have more practice on differentiation of chain rule. Log of x plus square root of x square plus 1, differentiation is 1 by that, 1 by x plus root x square plus 1 into differentiation of x plus x square root of x square plus 1. Once I have shown you the differentiation of x plus root x square plus 1, it is 1 plus 1 by twice the square root into differentiation of x square plus 1. That will become 2x, 2 and 2 getting cancelled. Once again I am taking the LCM. When you take the LCM, it will get cancelled and 1 upon root x square plus 1. Please be careful. This question is coming in higher order derivatives also. There is a question where log of x plus root x square plus 1 whole power m. There is a question is there. Therefore, please try to understand how to do the differentiation. Therefore, I have to put 1 there. When I put 1 there, it will become 1 by root 2. Therefore, the answer is 1 by root 2. Question number 5. You have been given the function is continuous. You have to find the value of k. You might have seen that the same type of question we have seen in 1 mark also. If it come in 2 and 3 marks, only thing difference is very simple. The limit calculation will be a bit lengthy, that's all. Let us go for the condition. It is continuous, then limit value is equal to functional value. Therefore, limit x goes to 0 I am finding. Now in the numerator I am having cos x minus cos y. I am using the formula minus 2 sin x plus y by 2, sin x minus y by 2. Therefore, the numerator I have used the formula and I get minus sin of 2x into sin x is equal to k. I have to split it into two standard limits for sin 2x by x and sin x by x. All of you know that for sin 2x by x, you have to multiply and divide by 2 to convert it into a standard limit. The constants will come out. Therefore, minus 2 into the limit x goes to 0 sin 2x by 2x and limit x goes to 0 sin x by x. Both are standard limits. The answer is 1. Therefore, k is equal to minus 4. Move on to question number 6. We have to discuss the continuity of. Let us move on to question number 6. You have to discuss the continuity of f of x, x power 4 plus 2x cube plus x square upon tan inverse x for x not equal to 0 and 0 when x is equal to 0 at x is equal to 0. We know that f of x is continuous when limit value is equal to functional value and x is equal to 0, functional value I am fixing, it is 0. Let me check out what is the limit value now. Limit x goes to 0, x power 4 plus 2x cube plus x square. From the numerator, x square can be taken outside. Now I have to split it into two standard limits. This is the way to do. By taking x outside, x square plus 2x plus 1 multiplied by x by tan inverse x. X square is written as x into x. I am getting two limits now. First limit x into x square plus 2x plus 1 normal limit. The second one to be converted into standard limit. If you know that limit x goes to 0, x by tan inverse x is equal to 1, you can do directly. Otherwise, you can do by this substitution. X is equal to tan t. T is tan inverse x. When x goes to 0, t goes to 0. Therefore, you are getting a standard limit as limit t goes to 0, tan t by t, which is a standard limit. For when I apply the value now, 0 into 1, therefore final answer is 0. Functional value and limit value are same. Therefore, f of x is continuous at x is equal to 0. Let us move on to the question number 7, parametric differentiation. When parametric differentiation is given, remember that when you have trigonometric functions as given in x and y, there is a possibility of simplification. Simplify, then do whatever they want. Whether they want the value at first derivative or they want to do the second derivative, always simplify and move. Let us now take a is equal to a sin cube theta. You know what is its differentiation? 3a sin square theta. Therefore, it is 3a into sin square theta into differentiation of sin theta is cos theta. Similarly, a cos cube theta, 3a cos square into d by dx of cos theta is minus sin. I know the formula for dy by dx. It is differentiation of y with respect to theta upon differentiation of x with respect to theta. Everything getting cancelled, you will get minus tan. Now, after simplification, I am putting theta is equal to pi by 3. The answer is minus root 3. Question number 8. You have to find dy by dx for cos x power y is equal to sin y power x. When it is function power a function, you have to use logarithm on both sides. Logarithmic differentiation. Taking log, y log cos x is equal to x log sin y. Here only you should be very careful with the differentiation of log functions. That also chain rule. Y into d by dx of log cos x plus log cos x into d by dx of y using product rule on the right hand side and in the left hand side. And I found this is the answer, minus y tan x plus log cos x into dy by dx. is equal to x into cot y plus into dy by dx plus log sin y. Bring all dy by dx to one side, and this is the final answer for dy by dx. And we have to take this assertion question number 9. The assertion is, if the function is continuous, then find the value of k is 2 by 7. Let us check whether the assertion is true. We are checking that f of x is continuous. It is continuous at x is equal to 5. It is continuous, therefore we are using that limit value is equal to functional value, and right limit, left limit values is equal to f of I. When I apply it, I am getting k is equal to 7 by 2, but it is given as k as 2 by 7. Therefore, assertion is false. Now, when I go for the function continuous at x is equal to a, then limit x goes a f of x is f of a. Therefore, the reason is true. Therefore, a is false, but r is true. To go to question number 10. The function f of x is not differentiable at x is equal to 1 is the assertion. Let us move on to question number 6. And we have to discuss the continuity of f of x. X goes to 0 plus of this is equal to limit x square upon tan inverse x. For x not equal to 0, definition of differentiability at x. Suppose if you know that nature of modulus function, you can directly come to the conclusion for assertion. But I am x is equal to showing you the vocabulary because it is 0. Suppose if the question is asked, show that the function is not differentiable, then you have to limit value now. Limit x goes to 0, x power 5 plus 2x f of 1 plus h. From the numerator x square can be taken and I am keeping everything. Now I have to split it into two standard limits. This is the way to do. In the limit, mod by taking x outside is h because plus 2x plus 1 multiplied by x by tan inverse x. X square is written as in the left hand side limit, mod I am getting two limits now because h is first limit 0, x into x square plus 2x plus 1 normal limit, not the second right limit to be converted into standard limit. It is not differentiable. If you know that limit x goes to 0, x by tan inverse x is equal to 1. But every differentiable function is continuous is given in the reason. Substitution. This reason is also x is equal to tan t, but this is not the correct explanation. When x goes to 0, t goes to 0 for both a and r. Therefore, you are getting